Assalamualaikum and hi again. For the second video, we will learn about solubility quotient expression Q. First, you need to write the solubility quotient expression Q. Second, calculate and apply solubility quotient in the prediction of the formation of the precipitate. Third, understand the concept of separation of ions by fractional precipitation and perform the related calculation. Solubility quotient Q. The use of reaction quotient Q to determine the direction in which reaction must proceed to reach equilibrium. Q, called the ion product, to represent of the product of the molar concentration of the ion raised to the power of the stoichiometric coefficient. The subscript 0 remind us that these are initial concentration and do not necessarily correspond to the dose at equilibrium. Expression for solubility quotient Q is same as for KSP. Will a precipitate form? Here, a reaction in the conical flask, we have the yellow color precipitate. It's very nice color there. A precipitate will form only when Q is more than K. When Q is lesser than KSP, what happened? It is actually unsaturated solution, no precipitate form. If let's say Q is equal to KSP, solution at saturation point of precipitation. Okay, baru nak jadi. However, when Q is more than KSP, it's actually saturated solution, precipitate forms. Sample exercise 1. Given the concentration of aqueous magnesium ion Mg2+ in the solution is 1.5 times 10 to the power of negative 6 molar. If 1.0 times 10 to the power of negative 4 hydroxide ion OH- is added to the solution, will a precipitate MgOH2 form? The value of KSP is given by the question. So class, we start. What we need to do first? The equation. So we write down MgOH in solid and supposed to have the double arrow, produce the aqueous cation and also anion. After that, we must to make sure the equation are balanced. We need to write down 2 for the hydroxide, since the coefficient for OH is 2. So we substitute the value of molar solubility given or the concentration given initial in the beginning of the question. So the question given you, this one is 1.5 times 10 to the power of negative 6 molar. For hydroxide ion is 1.0 times 10 to the power of negative 4 molar. So we need to write down the Q. Q is actually the product and also the reactant. However, when the reactant is in aqueous, so we not place inside the Q. So we substitute the value 1.5 times 10 to the power of negative 6 times with 1.0 times 10 to the power of negative 4. Okay, the product will be 1.5 times 10 to the power of negative 14. Mole 3L negative 3. At the end, we compare the value here. So we determine Q is lesser than KSP. When Q is lesser than KSP, that means the solution is unsaturated. So a precipitate of MgOH- will not form. Okay, next. Sample exercise 2. Predicting whether a precipitate will form. There are 200 ml of 0.04 molar BaCl2 are added to 600 ml of 0.08 molar K2SO4. Will a precipitate form? Okay, they're given the question BaSO4 KSP value. There are 1.1 times 10 to the power of negative 10. So now, according table that we memorize, BaSO4 is not soluble. So first of all, we need to calculate the number of mole Ba2 plus. For Ba2 plus, the molarity is actually 0.004. However, in BaSO4, there are ratio 1 and 1. So that's why we need to times 1 times the molarity, and then we need to calculate the times with the volume. The volume is 200 ml, so we need to convert in liter because the molarity that we use is mole per liter. So the bilangan mole for the barium is 0.08 mole Ba2 plus. Okay, sulfate. How to calculate the sulfate? Since in BaSO4 there are 1/1, so 1 times 0.0, sorry. What is the molarity? 0.08 from here, 0.008 times the volume is 0.6 liter, given the mole is 0.0048 mole of sulfate. Okay, after mixings, we know that V total is actually the volume is 0.8 liter. So we can calculate the new Ba concentration. Suppose 0.0008 mole divide by 0.8 liter. The molarity is 0.001 mBic ataupun mole per liter. Sulfate is 0.004 mole divide by 0.8 liter. It given 0.06 mole per liter. Now we do the equation BaSO4 in solid. Okay, BaSO4 in solid, we do the reversible equation. Arrow Ba2 plus in aqueous produce sulfate in aqueous. Okay, for the molarity here, we substitute 0.001. Here is 0.01 and this one is 0.06. Okay, so the KSP, this is a molarity, so we need to write down the Q. Q is equation product Ba2 plus. This is a Q expression, yeah. You need to write down even though the equation doesn't ask you to do. 0.01 times times the 0.06. The product of Q is actually 6 times 10 the power of -6. So from here we can compare the -10. Q is actually bigger than KSP. So when it's bigger, it's actually super saturated. So it will form the precipitate. BaSO4 will form a precipitate. Okay. To write down the proper manner, you can refer back to our slide that I give to you. Okay. Okay, next. Sample exercise 3. Predicting whether a precipitate will form. Predict whether precipitation will occur if 80 ml of barium hydroxide are mixed with 20 ml of iron sulfate solution. So we need to calculate the BaSO4. Okay, because here is BaSO4, so we need to calculate the bilangan mole first. Okay, mole for Ba2 plus in aqueous. So here is MV. Okay, the molarity given by the question in the BaOH2, we looking forward for barium only. So here we have only 1 mole. Okay, 1 stoichiometry, the 1/2 ratio kan. So 1 times the molarity. Okay, and then we need to times with the volume. The volume is actually 80, so we change to the liter. So this is the value for the bilangan mole for barium. Okay. Okay, 2 plus Okay. And then mole for sulfate in another solution here. Okay. What we can see here, iron is 2 and sulfate is 3. What I want to make sure you understand why I write 1. So this time we write down 3. Okay, 3 times with the molarity given by the question of the iron sulfate. And then times with the iron sulfate bilangan volume 20. Okay, so we get the value is 6.0 times 10 to the power of negative 7. This one is a sulfate. 2 minus 4. Okay. Okay. In the previous slide, BA is 1. Sulfate is also 1. So it's no issue here. Okay. For this time, in iron 2 SO4, the sulfate is 3. However, for barium is 1. So you need to be alert with that. To find the concentration of Ba2 plus, okay, we know the mole, so we need to divide by the total volume. So what is a VT? V total is 20 plus 80, right? So it's 100 ml. Okay. So 100 ml means we need to divide 0.1 liter. Okay. Is equal to 8.0 times 10 the power of negative 6 mole per liter. To find the sulfate, we need to show all of the working. Bahagi dengan 0.1 liter. Okay, this one is ml. Okay, the value is 6.0 times 10 the power of negative 6 mole. Okay, now we need to do the equation first. Okay, BaSO4 in solid produce in reversible, Ba2 plus in aqueous tambah dengan SO4 2 minus in aqueous. Make sure it's balanced already, and then we substitute below of the equation the concentration. 6 darab 10 kuasa negatif 6. So now what we do, the Q expression, Ba2 plus SO4 2 minus, and then we substitute the value 8 darab negatif 6 times with 6 times 10 the power of negative 6. Okay, the value for Q is actually 4.8 times 10 the power of negative 11. So we need to compare with the KSP given negative 10. So Q is lesser than KSP. So actually the solution is unsaturated. Okay, precipitate for BaSO4 will not form. Okay. Okay, next. Sample exercise 4. Predicting whether precipitate will form. Given KSP BaSO4 is 1.1 times 10 the power of negative 10. So what is the concentration SO4 required to just begin precipitating BaSO4 when the concentration of Ba2 plus in the solution is 0.01? So write down the equation first. BaSO4 in solid reversible to Ba2 plus in aqueous and sulfate in aqueous. So KSP value equal Ba2 plus and sulfate. Okay, this one we know already the value, right, for the KSP. So we just replace, and from here we know the concentration of Ba2 plus is 0.01 molar, but we don't know yet the sulfate concentration, because the question asking you to calculate the concentration of sulfate. So we just substitute, and then we get 1.1 times 10 the power of negative 8 molar. So from here we can compare. We know already the value of the concentration sulfate AC. Actually, this is the value when will begin to precipitate. Precipitate will begin at this point. Okay. Okay, next. When the concentration of sulfate ion in the BaSO4 solution reaches 0.01 molar, what concentration of barium ion remains in the solution? So, write down the equation BaSO4 in solid. Okay, in solid, reversible, Ba2 plus tambah, in aqueous make sure in aqueous, and sulfate in aqueous also. So, from here, we replace the KSP value. Okay, SO4 2 minus. Okay, and then we replace the value of KSP according to the question, -10. Barium we don't know yet. For sulfate, according to the question, is 0.015. So the concentration of Ba2 plus is actually 7.33 times 10 the power of -9 molar. Okay. Okay, next. Okay, there are practice exercise you can do according to the sample exercise that we do together. Okay, this is a selective precipitation of ion. Ion can be separated from each other based on the solubility of their salt. Consider a solution containing both Ag plus and copper 2 plus. If HCl is added to the solution, AgCl KSP is equal to 1.8 times 10 the power of -10 precipitate, while Cu2 plus remain in the solution because CuCl2 is soluble. Separation of ion in aqueous solution by using a reagent that form a precipitate with one or more but not all of the ion is called selective precipitation. You will do this experiment later. The lab assistant will mix up together Ag and also copper. So what you need to do, you need to add NaCl, right? So when it happen, AgCl is actually the precipitate. So you need to filter and take up all of the AgCl. So at that moment, you can find the solution is actually the blue color is actually CuCl2 is soluble. Okay, next. Sample exercise 1 as selective precipitate of ion. Okay, a solution contains 1.0 times 10 the power of -2 molar Ag plus and 2.0 times 10 the power of -2 molar Pb2 plus. When Cl minus is added, both AgCl and PbCl2, they are also given the KSP, can precipitate. Which salt precipitate first? What concentration of Cl minus is necessary to begin the precipitate of each salt? So, I give it already. Which salt precipitate first? The value that KSP lower will precipitate first. That's why I choose AgCl will precipitate first rather than PbCl2, because the value of the AgCl is lower compared to PbCl2. So now we want to calculate the concentration, okay, necessary to begin the precipitate. So we write down the equation AgCl. Okay, at this point we will produce Ag in aqueous and also Cl in aqueous. So to write down the KSP for AgCl is equal to Ag plus and also Cl minus. At this point, we know already the KSP value given by the question, so we just substitute. And then we just calculate this. Ag also is given by the question. So we substitute the value of Ag plus 1. Okay. And then Cl minus we need to calculate. Okay. Then at that point we can get the Cl concentration is actually 1.8 times 10 the power of -8 molar. Okay. However, for PbCl2 in solid, okay, it produce Pb2 plus aqueous tambah Cl minus in aqueous, but we need to make sure the equation is balanced. Okay. So here supposed to have 2. Okay, and then KSP sama dengan Pb2 plus Cl minus have 2. Okay, here. So after that, we substitute the KSP 1.7 times 10 the power of -5. Pb is from the question is 1.8 2.0 times 10 the power of negative 2. And CL we need to calculate. Okay, it's kuasa 2. So CL here we can get it simplify to be negative 2 molar. So at this point 1.8 times 10 the power of negative 8 molar is actually in excess. This very small concentration will cause AgCl to precipitate first. When we compare, this one is negative 8, smaller concentration compared to the Cl, the right side. So AgCl is easy to be precipitate compared to PbCl2. So you can refer the explanation with your lecture note later. Okay, this is the next sample exercise. When sodium dichromate is gradually added to a solution containing Pb2 plus and Be2 plus, which ion will precipitate, whether it's Bb chromate or barium chromate. So we need to compare the Ksp value. So if what you can see here, this one is negative 14, this one is negative 10. The lower the Ksp value is is preferable to be precipitate. So to answer the A, we just compare the Ksp value je. So Pb chromate we can understood is lower than Ba chromate. So definitely Pb chromate will precipitate first. Okay, so therefore Pb2 plus will be precipitate. PPT is precipitate first. Okay. So B, what will be the concentration of the ion precipitate first? So we know now, since we want to focus on PbCrO4, right? So we need to determine the concentration of ion to find Pb2 plus. When barium start to be precipitate, barium just begins to precipitate. So at this point, we need to know the barium chromate first. To know the barium chromate punya concentration. Okay, we write down the equation. Barium chromate, it produces a barium 2 plus in aqueous and also chromate ion in aqueous. Okay, so this one we know the Ksp expression. Ksp expression is actually the product in aqueous. We not include the solid in the Ksp expression. So we get this one after we balance it, and then we replace the Ksp value, and then we know here the concentration of barium in barium chromate according to the question is 0.01. So 0.01, but we don't know the chromate ion. So we substitute the value, and then we know the chromate ion is actually 2.4 times 10 the power of negative 10 and negative 8, sorry. Okay, molar. So this one is a concentration, but we still not answer the question. We just substitute to the Pb chromate that will precipitate first. Okay, so Pb2 plus in aqueous plus with chromate ion. Okay, so this one Ksp equal product Pb2 plus chromate ion. Okay, then we substitute the value. This one is 1.8 times 10 the power of negative 14 according to the question, and the chromate we place from the one that we calculate before. So what we have here, the concentration of Pb. Okay, here I proceed here. The concentration of Pb2 plus is actually 7.5 times 10 the power of negative 7 molar. What will be the concentration of ion precipitate first when the other ion just begin? So chromate ion just begin to precipitate. So what is the other ion yang precipitate first tu? Is focusing on Pb. So this is the answer. Okay, you may proceed with the calculation sample exercise, persistent exercise you can do. Okay. I also provide you the tutorial later for you all to prepare in your tutorial class. Okay. Okay, we have for the last topic, we will face to face, and we try to get all of the practice exercise that you do. If we have a time, I will call one by one to do exercise in front of the class. Okay, see you again, class. Bye.